This is the test on work and energy. Okay, we'll do the first question. Work done when a 5 kilogram is pushed along a smooth plane by a force 2 Newton for 10 seconds is. So we have 5 kilogram and the surface is smooth. So no friction. 2 Newton is applied. And this is done for 10 seconds, right? So as you know, in order to find work, you have to multiply force by distance. Force is given, displacement is not given. So you have to find the displacement, right? This is an easy question. F is 2. In order to find S, you need to use this equation. Initial velocity is 0. Then we don't know acceleration. So you have to find the acceleration as well. So to find acceleration, we have to use F equals ma. Force is 2, mass 5, a. So a is 205. 205 means 0.4 meters per square second. Then t 10 squared. 0.2 times 100, 20, right? 20 meters. Then you can substitute it here. Then the work is 40 joule, right? So it should be the fourth answer. Work is 40 joule. Second question. Work done when a 50 kilogram of mass is held 2 meters above the ground, right? So the same equation. 50 kilogram is held above 2 meters. So you are only holding that, right? It is just held like this. In the question, they don't say you moved that to a 2 meters. So you are just keeping it at a 2 meters. So while you are keeping it, there is no displacement. Displacement is 0. So the work done is 0. Right? Many have thought that it is mgh. You cannot apply mgh because there is no work done if the displacement is 0, right? No matter how hard you try, if the displacement is 0, work is always 0. It doesn't matter there is a force present in there. So the answer should be fifth one for that. Okay, third question. An object is carried on a Cartesian plane. The coordinates are given. This is y-axis, x-axis. So one coordinate is 0, 3. 0, 3 means here, right? Y 0. So these are xy coordinates. Here x 0, y is 3. And here you have x 4, y 0. So in the question they say from here to here, you move the object using a 5 Newton, right? So now you know the force and the displacement. So this length is 4, this length is 3, and this hypotenuse should be 5 meters. Force is 5, hypotenuse is also 5. Then you get 25 joules, right? 25 joules. So the answer is first answer. Then fourth one, on a particle force acts, and they have given the equation F equals kx. K is a constant. Work done when the object moves from x0 to x1. So here you cannot simply apply this equation, right? Why is that? With displacement, force changes. So this is a variable force. This is not a constant force. So you cannot simply just apply Fs. So as I mentioned, if you get a situation like that, you need to draw a graph. to get the variation. So it is a f equals kx similar to a y equals mx, right? So the graph is like this. Then from 0 to x1, so at x1, so this is the function of the graph f equals kx. Just substitute x1 here. So you get kx1 for this value, right? So you know the height and this length. Then the area of this graph gives us the work. So this is how you find work whenever you get a variable force, right? You can only apply Fs just if the force is given as a constant. Otherwise you cannot, right? So what's the area of this graph? Triangle, half, height is kx1, this length is x1. So half kx1 is squared. So that is the work done, right? That is the work done. So the answer should be third one, right? Kx1 is squared divided by 2, right? Then fifth question. A mass capital M attached by a string is lowered so there's the string, a height simple h, and they have given the acceleration that you lower this mass, right? So what they ask is work done by tension of the string. This is the tension. The answers are given in mg, in terms of mg. So I have to find this t in terms of mg first. So since you know the acceleration, you can simply apply F equals ma downwards. So the downward force is mg, upwards it is t, mass is capital M, acceleration is g over 2. So t is equal to mg over 2. So this is the tension of the string, right? Then if you apply W equals Fs, so this is the work done by the tension, right? So the force is upwards, see that? And the displacement is done downwards. So to opposite direction. Force and the displacements are to opposite direction. So you know in that case, work done should be a negative, right? Okay, so we know the force mg over 2. We know the distance, that is h. So W is equal to minus mgh over 2, right? Answer should be second one, right? Okay, sixth question. The graph below shows variation of force F with displacement S. Work done by the force F is, right? Okay. So the variation of the force is given by this graph against the displacement. So you just simply have to find the area of the graph in order to find the work. Only confusing part here is there's an area to this side, right? But you have to know that this also is a positive work. The whole thing is a positive work. You don't subtract this area, right? If you need to subtract that, force should be negative. The graph should be like this, below the s-axis, right? If the area is here, you don't subtract that area. You just have to add. You just have to take the area of the whole thing, right? I'll just explain that further. So here you have the origin. Displacement 0, origin. Minus 2 meters, meaning it is behind the origin. Then you have 2 and 6, like this. You can see that if the positive direction is to this side, force is always positive, right? So the object is moving from here to here, force also is to the same direction. Here as well, when you are doing the displacement to this side, force is to the same direction. So in none of these places there's a negative work. For both areas are positive, right? So you just have to find the total area of this, which will become the, which is the work done here, right? So this is a trapezium. What is this length? 2 plus 6. So this length is 8. This length is 2. So 8 plus 2 divided by 2 times height, that is 4. 10, 10 times 2, 20. So that is 20 joule, right? The area of this graph is 20 joule. Third one is the answer there. Seventh question. Image shows a vertical cross section of a smooth path. A mass of 2 kg starts sliding from point A. Kinetic energy of mass at C is. So these remaining questions are from energy, right? So the previous questions were in work. So you have this path. So we will say this is the potential energy 0 level. This height is given as 14 meters, and we have the point A. Mass is kilogram, 2 kilogram. This is A, and we have a C, point C, and there's a point B. This side is 5 meters, this side is 7 meters. Okay. So what they ask is kinetic energy of the object when it reaches C. So they say that this is a smooth path. So there's no energy loss, no friction, no energy loss. So for a question like this, you cannot apply motion equations, right? Linear motion equations, because the path is not linear. The only way to solve this, you have to use energy conservation. Meaning that you can say energy here, let's say EA, total energy here is equal to total energy here. That's what you can say. Because there cannot be any energy loss, right? No friction, no energy loss. So about energy, work and energy, the advantage of that is you don't have to think about directions. You only have to think about magnitudes, transfer of energy. If the energy, total energy is a constant, if one type of energy decreases by the same amount, another type of energy would increase. So the total energy would remain constant. So this is what happens here. So initially it is pushed at 0 meters per second. So the kinetic energy is 0. Kinetic energy is 0. So as it lowers, potential energy decreases. By the same amount that it decreases, kinetic energy increases. Right? So let's say how to apply that. Here the initial velocity is 0. So the kinetic energy is 0. Potential energy, so that is mgh. Mass is 2, g is 10, h is 14. Right? Equals to energy here. But in this case, we have both kinetic and potential energies. The object has a velocity here, right? So that's what they ask. What they ask is kinetic energy here. I'll just put Ke to this point plus potential energy. So what is the potential energy? Mass is 2, G is 10, H is 7. So this is 140, this is 280. So 280 minus 140 equals Ke. So it is 140, that is the kinetic energy at point C, that is 140 joules. Kinetic energy at point C, that is 140. So you can see here the kinetic energy is 0, but the potential energy is 280. So it's a good question to understand this energy conversions, right? Here the potential energy is totally 280. Here kinetic energy is 0. So as it reach here, the total energy should remain same. Here kinetic energy has increased to 140 joules. The remaining energies also should be 140 joules. So the total energy is 280 joules, right? 280 joules. Okay. So what they ask is the kinetic energy. So it is 140 joules. First answer. Okay. Eighth question. Two pendulums with the same length is arranged initially as shown by the image. When the inclined pendulum is released, it hits another pendulum and moves as a one pendulum. Maximum height compound pendulum moves is, right? So there you have a pendulum vertically at rest. Then you have an inclined pendulum. Then you release. So what happens is this moves along this path and it hits. So once they hit, they attach together. Then it starts to move to a height, let's say simple h. So what they ask is this simple h. So in this case, can't we apply energy conservation? Can we say that energy here is equal to energy here? You cannot say that, right? Because there's a collision. So as you know, when they after the collision, if they attach, it has the maximum kinetic energy loss. So there's the energy loss. So you cannot say the energy here is equal to energy here. Right? So you have to apply momentum conservation for this collision. Okay. So this object comes here, let's say, once it reaches here, just before collision. Let's say it has a velocity u. This is just before collision. After collision, after these two attach together, let's say they move at v, right? So this u and v we have to get in terms of the given terms. So first let's find u, right? So to find u, easily you can apply energy conservation. You are applying that only for m1, right? Okay, so energy here. So if we take this level to be p equals 0 line, the energy here is m1 g d. Energy here is m1 g d. As it reaches here, that total potential energy becomes 0. So that has converted into the kinetic energy of m1. So you can say half m1. Let's say the speed is u is square. Then m1 cancels off. You have 2 EE root. So u is equal to 2 ED root. So this is the velocity of m1, right? Just before the collision. Then for the collision, you need to find this v. So for the collision, you have to apply momentum conservation. So just before momentum of this boat, 2, right? This is a rest, but this has a velocity. So m1 u, m1 u. Momentum of m2 is 0. Then these two attach together. So we can say m1 plus m2 both have the same speed. That is what attaching means, times u. Then this v is equal to m1 u divided by m1 plus m2. Then we can say this v is m1 u. Instead of u, you can use this, right? Because we have to make this in terms of the given terms. So if we need v, we can find that, right? So we just applied for that to the collision. Then we have to find this height, the maximum height it reaches. Then for that one, you just have to apply energy conservation again. That is after the collision, right? After the collision, there's no energy loss. So the energy here is equal to energy here. That is after the collision. Again, apply energy conservation. So after the collision, this has potential energy is zero. At this time, potential energy is zero. Kinetic energy is half m1 plus m2 v square equals m1 plus m2 goes to a height simple h. Okay. Then m1 m2 cancels, so half v square. So this is v. You have to take v square. So just substitute the square of each one. Right? m1 square divided by m1 plus m2 square times 2gd root. So it becomes 2gd. This is equal to gh. So we have to find h. G cancels off. These two and these two cancels off. What do we get? H equals m1 square divided by m1 plus m2. You can put the power common as a common term. Then you get simple d here. Right? So this simple h is equal to m1 divided by m1 plus m2 square d. This is simple h. Okay, so the answer should be second one, right? Second one. So I'll just explain again. So from here to here, for the M1, you just apply energy conservation. Then for the collision, you apply momentum conservation. Then we need to find the maximum height that these two goes. So again, we just apply energy conservation to find that maximum height. Right. Ninth question. A uniform chain with mass capital M and length capital L is on a table. So let's say this is the table. Part of the table. So you have a chain. I just wrote the chain like this. Okay. So the mass of the chain is capital M and the length of the chain is capital L. And they say one n fraction of its length is hanging by edge of the length. So here, if the total length is L times 1 over n is hanging by the edge of the table. So the remaining part should be what? It should be L minus L over n. You can take L out, 1 minus 1 over n. L, 1 minus 1 over n. So this part is this much and this part is this much, right? So this is the hanging part of the chain. So what they ask is a minimum work required to get the hanging part of the chain on the table, right? Right. So we have the hanging part. So by pulling this chain, you can pulling this chain to this side, you can bring this part also on top to the table, right? Meaning, so if the table is like this, the whole chain should be on the table, like this. So as you can see, so when you place the chain like this, when you arrange the chain like this, so what changes is the center of gravity of the chain. Center of gravity of the chain has moved onto the table. Center of gravity of the chain has moved onto the table. Right? So when you move the center of gravity of the chain upwards by that amount, potential energy of the chain increases. So that potential energy is the minimum work required to bring the table onto the, bring the chain onto the table. So the first thing is you need to find the center of gravity of this arrangement. So here the center of gravity is at the center, here also at the center, right? So in between these 2 points, let's say this is O1 and this is O2. So in between, you have the center of gravity of the chain. Center of gravity of the chain. Right? You have the center of gravity of the chain. So you need to find the position. You can consider this triangle. Let's say this is A. So let's say this is O1, this is O2. These are the center of gravities of each part. Right? Then the center of gravity here. This is what we need to find, the location here. Let's say that is G. Right? So we took this as H, sorry, A, and let's say this is X. This length is X. So this is what we need to find. The center of gravity below the horizontal line. So if you can find X, this is the amount that you have to lift this system. Right? So if you find X, you can simply get increase of potential energy, which is minimum work required. Right. So how do you find that? So we know that, let's say, this part has a M1 mass. This part has a M2 mass. M1, M2. So you know that the center of gravity here is in this proportion. M2 to M1. Right? Here the ratio is M2. This length is M2. This length is M1. This length is M1. This length is M2. So it should be the length proportion. It is inversely proportional to the mass. So the higher the mass, lower this length. Right? So M2 is here, M1 is here. Right. So let's say if this is the proportion here, M2 to M1, you can see that this triangle and the large triangle, those are similar triangles. So the ratio here also should be the same. If it is, so here the ratio should be M2 to M1. That is the length ratio here to here. Right? And this AO2 length, we know that. AO2 is what? Center of gravity is here of this part. It should be L over N times half. So this length should be L over 2N. Center of gravity is located at half of this length. So we know the total length of AO2. So all we have to do is just find X. So how do you find X? X is equal to M1 plus M2. Just add these two ratios and we need to find the length related to the M2, right? M2 times total length. Total length is of this part is L over 2. Right? So that is what we have to do. But this M1 and M2, those values should be in terms of what we got, what is given in the question. So we know that M2, right? M2 here is proportional to the length of this whole part. The mass of this part is proportional to the length of this part. So instead of the mass here, you can use the length. Okay. So when it is in a ratio like this, you can use the length instead of mass. Even if you get, if you exactly you need to get if it is given in a fraction like this, instead of mass, you can use even if you use the cross-section density, they get cancelled out, right? Because that is in a fraction like this. Okay, so instead of M2, I'll use length of this length, that is L over M, divided by M1 plus M2. M1 plus M2 means total mass. So what is the total mass? You can use length, right? Use L. Total mass is L. Right, this L cancels, so then you get a 1 over M. 1 over 2M, right? L over 2M. So that is the X value. X means this much. This is how much that you have to lift the center in order to bring that chain to the tail. Potential energy required for that is what? Which is work. Times L over 2M square. So this is the potential energy required, which becomes the work, right? MgL divided by 2M square. The answer should be third one for that question. Okay, 10th question. A ball is released from a height, simple h. Its energy is lost by 25 seconds. Sorry, 25%. 25% when it hits the ground. So whenever it hits the ground, the energy of the total energy of the ball increases by 25%. Height it reaches after third hit on the ground. Okay. So let's say we had a potential energy MPH, right? Which is the total energy actually. So it is released. So it comes down. So the 25% of energy is lost. So the remaining energy is 75%. So using the remaining 75%, the ball goes up. This is the first hit on the ground. The ball goes up, but this has 75%, meaning 0.75. So if it has 0.75, this is 100%, right? MPH is 100%. So here you can see that it goes 0.75 H maximum height. Okay. Okay, then let's consider the second hit on the ground. So now the ball is at a 0.75 H. So from 0.75 H, 25% is lost. 75% is remaining inside. So it hits the ground and goes 0.75 square H. Square means now the remaining energy is from 0.75 times 0.75. So from that you can find the maximum height it reaches. Right? So at the third hit, it goes up. So again 75% is remaining. So again you have to multiply by 0.75. So this 0.75 cube. So it could go up to somewhere here. Right? So you can see that the height the ball reaches gradually decreases. Right. After the third hit, the ball reaches 0.75 cube. 3/4 cube h. Right. 3 cubes means 9 times 3, that is 27. 16 is 64 h. So capital H is 27h divided by 64. So it should be the second answer, right? Second answer. So here you cannot apply. You can apply, but it is very time consuming, right? Energy conservation. So for once you know for a one instant, so we know that always after the we can figure out after the collision, always it goes up to it goes up to 0.75 amount the previous height. So using that pattern, you can figure this out. So let's say like after nth collision, so after the nth collision, it has to go up how much? 0.75 n times h, right? So this is after the nth collision. So you have to figure out the pattern there, right? Right. 11th question. A mass of 0.4 kilogram is projected upwards at 10 meters per second. Average resistive force acting on it is 2 newtons. Its speed it hits the ground is. So we have a mass 0.4 kilogram and it is projected upwards at 10 meters per second. So it goes up, comes down. So what they ask is velocity this ball hits the ground. So if there is no air resistance, we know that velocity should be 10 meters per second, right? But there is air resistance, so it slows down the ball. Right. Let's say this is 1, this is 2, and this is 3. So let's say this height is simple h. Height is simple h. Okay. So from 1 to 2, I'll just apply energy conservation. P equals 0 is the P equals 0 line. So here the energy, it is only as kinetic energy, that is half. Mass is given as 0.4. V is 10. 10 square equals potential energy here. So 0.4 mgh, right? M, G is 10, H is, we need to find that, H. So is this correct? This one. So here you have a kinetic energy, right? So once you project this upwards, constantly there's a 2 Newton of a resistive force downwards acting on the ball. So this resistive force eats up the total energy of the system. So here you have a total energy of this much. So part of that energy is converted also into the work done by the resistive force. Right? So part of that converts into the potential energy. Part of that converts into the work done by the resistive force. So the resistive force is 2. It does that from here to here for a simple h distance. Force times simple h distance. Right? Okay. So here we need to find simple h. 0.2 times 100, that is 20. 2 times 100, that is 20. Here you have 4h plus 2h. So you have 6h equals 20. So h is 10 over 3. Height is 10 or 10 meters divided by 3. Okay. So what they ask is this V. So again we have to apply energy conservation. Right. So let's say energy here is as mgh. And you can see it. mgh stands for 0.4. It is in pound h. 10 over 3. Okay, so that is now the available energy is this much. So that energy is consumed, part of that energy is consumed by resistive force as it moves down. So here we can say resistive force is 2. Height we already know that. That is 10 over 3 we found, right? So this is Fs. Plus, as it reaches here, the remaining part should be in the type of kinetic energy. So we can say a half mass 4. We need to find V square, right? So here we have 100. So 100 times 0.4, 40. 40 divided by 3 equals here 20 divided by 3 plus 0.2 V square. Take this to this side. So we get 20 over 3 equals 0.2 V square. So divide by 2, you have 0.1, 10. Then you get 100 divided by 3. So this is V square. So do we have, let's see. So take the square root, you have 10 divided by root 3 meters per second. Right? So this is the velocity it hits the ground. See that projected velocity is 10. It hits the ground at this velocity. 10 divided by root 3 meters per second. Right? Apply linear motion. Two or three equations. But using just the one equation, using energy conservation, find the whole order. So here you have a potential energy. So what you ask work. So here you can see the only difference. Right. 14. Simple pendulum with L is held, so it makes an angle theta with vertical. When it is released, the speed it gains at the bottom of its motion is. Okay. So this also is a typical question. So we have a simple pendulum and this angle they say theta, mass is m. Now the length is given as simple m. When it is released, the speed it gains at the bottom of the speed gain here. So here the potential energy is 0. Right. So here as well you can usually use the energy here is equal to energy here. Yeah. There's no energy loss. Right. So what's the energy here? So let's say this is L cos theta. Yeah, this is L, this is the adjacent side, so this becomes L cos theta. So if this is L cos theta, this is total length of the string. So this length should be L minus L cos theta. This total length of the string is L. Let's subtract that from L cos theta. This length is L minus L cos theta. So I just found that. Right. Here the potential energy. That is m g. Height is L minus L cos theta. So this potential energy is totally converted into kinetic energy here because potential is 0 at this level. So the kinetic energy here is half. So the mass is m and v square, right? M cancels off. V is what? Take 2 to this side. 2g. I'll take 1l out. 1 minus cos theta. And take the root of the whole thing, right? So don't write many lines. You should be able to do these calculations at once, right? They don't give you marks for writing unnecessary calculations, right? they give you marks for the correct substitution. I mean, in essays, for the correct substitution for the equation, then just substitute correctly without doing any modifications to the data. Then you can at once take the answer. Don't write too many unnecessary calculations. Right? You should be able to do some of the calculations in your head. Right, 15. An object moving at √3 meters per second can just penetrate a wood plank. Right? Just penetrate. Here it stops. Right? So if we have a tree wood plank, what we have to do is the meaning of the pressure is anti-kinetic. So as it penetrates, there's a resistive force acted by the plank of the bullet, right? Object. Of the object. So the resistive force eats up all total kinetic energy for the test benefit. So if we can see like half mv square is totally consumed by Fs. F means the resistive force. If you want, you can use a proportional method. You know that at the next case, there are 3 wood planks, right? So 3 times the thickness. 3 times the thickness. So let's say thickness here x. Here it will be 3 x. 3 x. And the resistive force is constant. You can say same object at both cases. When you compare these 2 cases, it's the same object that penetrates. So this m half is constant, m is constant, resistive force also constant. So you can see. So you can use this proportionally. It is easier actually. Okay. So for the first case, I'll apply the proportion. So it is √3. √3 is going to be 3. And let's say this x plus proportion. So for the second case, we need to find, for this purpose, we need to find the velocity. So u square proportional to, now you have 3 times 3 x. Is second divided by first. So u square divided by 3 equals 3 divided by 1. So u square is 9. So u is 3 meters. So here the speed required is √3.